solid that is incompressible, okay, which are liquids. Because the volume of a liquid, when you put pressure on it, doesn't change. In other words, you can't squeeze a liquid into a smaller volume. You can do that with gases.
You'd be surprised.
Because liquids, if you look at them on the atomic scale, the atoms of a liquid are right next to each other. So there really is no space to push them tighter. Whereas with a gas, your atoms are very far apart. So you can compress gases. You can't compress liquids. Now the difference between a liquid and a solid is that your liquids, these atoms are not tied together. So they're able to roll over top of each other and assume the shape of the container they're in. With a solid, those atoms are all bound together by a crystal structure, so they can't change their shape. But solids are incompressible because of their crystal bonds. Liquids are incompressible because the atoms are cheek and jaw with each other. They're right next to each other. So you can't squeeze them into a smaller space. Gases you can. If you have an incompressible fluid, then the pressure is transmitted through the fluid without any loss. And this is the whole concept behind pumps. Okay, like hydraulic jacks that lift up your car, or hydraulic rams that they use for like running bulldozers or that type of thing. What you do is you take a system and you fill it with a fluid. And you exert a force
hydraulics
on the small end of your system. So here you've got force over an area, which is a pressure.
Just tiny.
Now, if this fluid is incompressible, that pressure is transmitted without loss across the entire fluid. Okay? So let's say this is a square centimeter, and I'm exerting 10 newtons. So I have a pressure of 10 newtons per square centimeter. Okay? That pressure is exerted equally throughout this whole fluid. When I get to this side here, I've got a much larger area. Well, the force on this area is equal to the pressure times the area. My pressure is undiminished, but my area gets bigger. So my force gets bigger. So a little bit of force here translates into a huge amount of force here if my area is big enough. So you've got these, hydraulic rams that will crush a car. Well, they operate on a very little pump at one end of the system, and that pump is generating a relatively small pressure here, but the size of the ram jumps that force up exponentially because my area here is so much bigger than my area here. And this is Pascal's law. Pascal's law says that pressure 1 is equal to pressure 2, which is force 1 over area 1 is equal to force 2 over area 2. And where you gain the force is that F2 is equal to F1 times A2 over A1. In other words, just multiply both sides by A2. If area 2 is big, and area 1 is small, then F1 can be small and F2 can be quite large. And so when you pump up the jack on your car, okay, if you open the thing up and look inside, the little piston that you're operating is tiny. But that piston operates a second piston that's much bigger. And so the pressure that you are exerting on the little piston transmits equally to the big piston. So the pressures are the same, but because the areas are so different, the forces are very different. So as you increase the area, you will increase the total force, even though the pressure is staying the same. Because your pressure is force over area, so pressure times area is equal to force. And you can have a small pressure but a big area and generate very, very, very large forces, okay, from a relatively small pressure. So again, things like hydraulic jacks, the hydraulic rams that they use for operating the buckets on bulldozers and heavy equipment, they all have little pumps that create a pressure here, but because of the relative sizes of the areas over which those pressures are exerted, you generate large forces here from a relatively small force over here. And the difference is the area. So Pascal's law, basically pressure 1 is equal to pressure 2, or pressure, which is force over area. Force 1 over area 1 is equal to force 2 over area 2, which then flips to this. The force out is the force in times the larger area 2 over the smaller area 1.
Please pardon this interruption for afternoon announcements. It's not too late to join the Black History Club. There will be a meeting in room 212 on Tuesday after school.